There we go. All right. Take it away, Kevin.
All right. Get the right screen up here then. Well, welcome everybody to the SoCal PowerShell user group. It's been a long time since I presented to you guys, so I appreciate you guys having me back. Many of you probably already know me, but if not, I'm Kevin Marquette. I am a PowerShell MVP. I've presented the summit several times. Today, I work at Amazon, and today I'm here as a community contributor, just kind of talking about classes. So I guess the starting point here is I do have, and I'll drop a link to it here. I always keep all my presentations out on GitHub because it's easy to go download and grab the whole collection of them. But I'm going to drop a link to this out in Teams real fast. If anybody wants to grab or have this for later. And we're just going to jump right into it here. So set up my session and PowerShell classes. So I asked Matt to give me those topics that you guys wanted to hear about, since I can kind of present on quite a few of them. And PowerShell classes was one of them that jumped out to me as one that I could probably do, a fairly good. I've worked with them quite a bit, and I kind of know some of the struggles that people go through when they're trying to learn them. So PowerShell classes. So as we know in PowerShell, everything is object-based. Like we've been told that from the very beginning. If we run like a get service, right, we get several objects back. And then we can do, we can get a single instance of an object by assigned to a variable. And if we look at it, we have all the properties in the world on here. Like this one here, it's its path name, it's got a description, username. So we can explore these objects, once we have them. And then we'll get member, right? Lets us actually enumerate and see all the fun details of what methods and properties exist. Like get service, for example, they've got methods for starting and stopping the service. And here towards the very top, there's a type name. This is like type of the object. Now, I know we don't pay attention to that all that often, but as we're building classes, we'll see that this, becomes more of a useful property for us that tells us what type of object this is. And then there's actually some direct methods that can give us a little bit deeper of a dive into, just the name or the full name of this specific object type. So I'm just going out here to kind of prime the pump to think about, objects and classes. And we're actually going to walk all the way backwards to, ways that we return data in PowerShell. It mostly used, in the pipeline or whatnot, because we have this common pattern of A pipes to B pipes to C, right? We get some data, we process some data, and then we do something with the data. So quite often, we're working with, say, hash tables. Like it's super common to have a function that returns a hash table, back to the user. So if I load this function, and we name myself here, we're gonna get a hash table. Down below, I see all the key value pairs for that hash table. Now, sometimes we need something a little bit more structured. So that's where PS custom objects comes into play, right? Sometimes you want something that's more like table-like. Great for exporting to CSVs. So here I'm going to do this exact same thing, and we're going to create a custom object on the fly with a PS custom object, and I'm using like this hash table notation to define it. And when we run this now, I get this person that's this my first last name and the city. Now, I think it's an age-old question, like which one do you use when? I think it's fun when people discover a PS custom object because they're able to go so long without ever having to use it, because they can get by with just using a hash table for so many types of data. It's like you don't need a hash, you don't need a custom object until you need that structure. So, and we kind of have the same journey with classes. So I'm going to take the same example here, or this example, and we'll do it using classes. So I've got a basic class definition here. Right? We use the class keyword to say this is a class, and what this really is, it's defining like a template for an object. It's the definition of what this object should look like before I go and use it. So in this example, I'm saying this class has 3 properties, 1, 2, 3, and there's strings in this case. The type is optional, but highly recommended. Like this would still be a valid class just by declaring a variable, but yeah, so now I've defined my class and I've loaded it. When I return my instance now, I actually load my function, an instance of it, I now have an instance of that person class. But on face value, this is the exact same thing we did with the PS custom object. But we can do the same thing where we can save it to a variable, just like we did our service up above. If we do get member on it, you know, we see the properties, city, first, last. There's some automatic methods that every object gets. ToString, we'll have some fun with him later. And then my type name is of type person. But this actually comes back to, in a way, why classes aren't all that common in PowerShell, because in many cases where you would do something like this, you could just use a PS custom object. So that 95% of the places where in, like, if it was a different language like C#, everything is an object, but you also have to like define your classes up front. You know, it's a statically typed language. It's very rigid in that. So because PowerShell is being dynamic and very flexible, it's allowing us to get by without having to use a class for so long. So many people will probably spend their entire PowerShell career and never create a class or even run into code that's using classes. And that's perfectly fine. And this is a strong reason for that, because the CS custom object is so strong at creating this dynamic class that all the easy use cases, it's just almost easier not to have a class in there. So what that kind of means for us is that using classes becomes more of this edge case and more of an advanced use case within PowerShell. And it's, I suppose that's why I say we went so long without even having classes, because this is a feature that was added in PowerShell 5. And up until then, you know, we could get by with our custom objects. And the driver behind that was Microsoft internal developers. They were wanting more of the features of classes as they're pushing into DSC, and they didn't feel like they had the right tools they needed in the language. So the classes were really a feature for the developers. And if you see people that's making heavy use of classes today, it's more than likely they have a development background from another language. So I just want to set that expectation that we're going to dive into classes and we'll learn some fun stuff with them. But if these become like a challenging topic, just know that it is definitely an advanced feature, and you're not missing much if you're not using them. But learning to wield them in certain ways can give you a lot of power on your scripts. So with that, let's kind of continue on down on some of the syntactical pieces of classes. Right, we've already created an instance using this hash table syntax. And we can do the same thing. Yep. Make sure that the code highlights here. Get my object. We can actually do the same thing by calling the constructor. We say, give me a new person, or it'll give me an empty class, and then we can assign the properties one at a time. So yeah, these two are effectively equivalent of each other. I personally like this style where we can get away with it. So one fun thing that PowerShell lets us do is very flexible with is be able to cast objects, like hash tables to an object. So you can actually get by with defining your hash table up front, and then casting it to a person, to my class, to create the object later. So if you're one of those that likes to create, pull all your properties together and wait until you need the class to create the class, you can do that. I do that with PS custom objects all the time. And the same trick actually works with PS custom objects. So if you have a PS custom object that has all the same properties, you can create it and cast it to your class. So all right, so now we've got this structured thing that defines what an object is. We can take it one step further and actually add default values. So here I've got person 2, and I basically pre-signed default values to these properties. So when I create my instance now, I don't have to assign them later. This is good for if you have like timeouts or certain things that are just common across all your objects that you can just preset them to same defaults. And then here I can like create an instance of a class and just overwrite the first property, the first name of it. And I can see that, just the first name was overwritten and the other two defaults are still in place. Now where we start to separate ourselves from PS custom objects and into, more powerful classes is that you can actually have methods on your classes. So it's like data with functions. So I've got person 3 here. I look at my same 3 default properties, but now I've added a method. In this case, to say get the full name or like format the name in a certain way, and I'm specifying the format I want to use and passing in the first and last name into that. Now, a couple things going on here is this is a function definition effectively, where I'm defining the return type as a string. So PowerShell classes are much more rigid in that it wants to know what's coming back out of it. So you have to define the return type of a function, and you actually have to tell it you're returning something. So in a normal function outside of the class, you might just put something on the pipeline and the value comes back to you, like I was doing up to the early examples. But here I'm getting an error saying that I've got some values that are not returning, or not all code paths are returning a value. So it's telling me I actually have to use the return keyword and to get a value back out of it. And then the other thing I kind of glossed over is that to actually access the properties and methods of your class, you actually have to refer to this instance, and that's what this keyword is. I want this instance's first name. I want this instance's last name. Let's see. And another example of a method that doesn't return any values, we actually use the void keyword. So here I'm adding like a wave function that's just doing some verbose output. So if I call this, I just say, I'm not returning anything. So let's use the void keyword, and everybody will be happy here. So let's go ahead and load this guy up. Let's create a new person. If I do the get full name, it's going to execute that code. So I see if we're using more of a proper format, last name, comma, first. And if I just say wave, it's going to execute some verbose output without any return values as we defined it. I called out toString before, and this is kind of a special function that every class has. And this is what makes it so that if you actually use an object in a string, it will actually provide the value that should be placed there. So I've got the same properties, get full name, but I'm overriding this automatic function with my definition of it. So here I'm saying I want the full name to show up anytime this guy is used inside of a string. So let's load this class up. And I've got, this is person 4, and I got the person from my previous example here to just kind of show you side by side what happens. So in this case, the first one, because we did not define a toString, it just puts the name of the class in there. And because I override the second one, I was able to just use my format string, my formatted name inside the string here. So that's a very common thing I do on classes is, you know, if they ever show up in my strings or in the like if you're doing like a format table even, like on a property, this lets you see, you know, a nice clean representation of that property, of that field. And then constructors. So we're using the default constructors before, so we didn't have to think about them at all. And in this case here, I've got a person that has 3 properties, and I'm creating this rule that says anytime a person is created, you have to provide a first name, a last name, and a city. So we're not letting you just decide on. I'm saying I want all of these properties provided, and let's load this guy up to see what that looks like. And so here's a case where I'm saying I have to have all 3 of these properties, and we'll create this instance, which creates the object like we expect. But now if somebody tries to create one without providing any data, we're actually going to get this error that says, cannot find an overload for new, and the argument counts 0. You've probably run into this with other, you know, classes, like .NET classes, trying to create instances of them. And this is really what it's talking about in the covers, is that the definition of how you create an instance of it is particular, and you have to provide exactly the parameters that it's asking for. The downside of this, so what's nice about this is it lets you do some validation, right? If I say this thing will always have 3 properties, and I can validate when it's created, I don't have to validate them later. I know it's good up front. The downside is I can't use this other magic syntax here to create an instance of it, because it's complaining because it can't create an instance without that. We're not using this constructor. Now, if you actually still want to support the default constructor and have your own for various reasons, we can actually add in a constructor that takes no parameters and has no return value, and that will enable those. And I guess I kind of glossed over it, but the constructor is very specific in its design, and it must have the same name as the class, and it has no return type to it. It's a very common convention that we see in other languages as well. But this is defined as the very first time this thing is created, this is the code that runs, used for initializing content or initial validation of these properties. But since I've uncommented this now, the new will give me an empty one back, and this person 5 will still work. Excellent. Okay, so let's take a look at a real class. Like, you know, sometimes it's hard to think about these abstracts of these persons. Very common when you're learning about classes, they say, oh, I got this person or this car or this animal. And let's look at an example from a real project here. So this is a project where, you know, back before I really had ARM templates or CloudFormation templates to define and build some infrastructure, I kind of like create that on my own. So I had internally, I had like this load balancer where I had my configuration that defined how it should be, and then I'd code was basically applying the configuration. And as part of that, I had some like tests that were ran to decide is there drift or not, and I use that to decide to apply the settings, or just give me a report of what's drifted. So to set that up, I kind of use 2 classes here. This first one is a test item. It's like an individual item that I'm testing. You've got 2 properties. I've got the results, like did it pass or fail, and a small message describing exactly what it was. This is a case where I always want these 2 things provided. So I have a default constructor that takes in the message and the test results. And so they always have to be there. And they're signing them back using this keyword. And then I overrode the toString to just show the message. So this class is each individual test that I'm performing. And then I have a larger class that is actually going to contain all of those and keep account of what's been going on. So I'm going to track the total count, the passed, and the failed, and I've got a list of test results or test items called test results that I'm going to shove all these results into. My default constructor here is just initializing these values. I just as easily could have had these set up here instead, but I think I don't remember why I chose to do it inline or down here, but I did. Both approaches are very common. And then I have some helper functions that says, hey, if this failed, like I say this result, I had a failed test and give it a message, passed test, or just add the results with a message and a result to it. These guys are just calling the add results. So the message and results are used to create a new item. I update my counts for my total, and if it passed, I increase the pass or fail count, a little verbosity so we see if it was working or not, and I add them to my list. So basically, I've got a collection of tests. And then to use this, all right, I'll make sure these guys get loaded. I gotta load this one first. It's loaded. Test results is loaded. And if I run this up, it's basically, you might ask why I wouldn't use Pester for this case, like just kind of going off on that tangent. And it's the idea that I actually want this like inside my logic of my code to be testing stuff and then take actions based on the results. And I don't feel that that's a good spot for Pester. Like I see Pester as like format table, right? You do all your pipeline work. The format table is always at the end. In a way, Pester should be on its end, and then it shouldn't be like feeding back into your application logic. I can see an exception for like your pipelines for like CI/CD, but if you're testing and taking action on it, I think having more control over that makes a lot of sense. So, but now that I've got this class created, result created, I could be doing tests and in my logic say, well, if this happened, this thing failed. So, or this passed. So I'm like, all right, here's the pass result. We created an instance. We added some tests. Oops, we made a mistake of some kind. And then I can use that result that uses the true or false here. I'm doing something random here to represent something that could toggle or fail at any time. And then if I actually check my results off that, I've got total count, pass count, failed count, and a collection of all the items. I can actually even dive into the test results now to see specifically, of the results in the message, which ones passed and which ones failed. So it's kind of inbuilt reporting. So, there's many ways to approach this problem. Many ways I could have solved it, but I think to me, this structure just kind of almost jumped out at me. It's like, oh, if I just have this collection of test results, that things would be very clean to work with. And I do have an example here from the code where I actually pulled this from, where I'm basically going to say get test results. There's some general setup for this function. This is actually on the health monitor for this load balancer. And I'm basically just calling add results, and I give it a message like this monitor exists on this host. And I do the check right here, null, not equals, existing config. And then I have properties I'm checking, send, receive, timeout. And so I'm actually doing a lot of testing validation in here that was able to abstract and push away a lot of the logic behind the class to keep track of the counts and things along the way and kept this code tighter. So what I want to do now is kind of check in. If they have any questions or comments, we're going to add them in the chat. I just want to touch base on where we're at because classes, I think I've covered the basics of it, and it only gets more complicated from here. So if there's something you feel like I glossed over a little bit too fast, that'd be a good time to like ask your questions, and we'll see if there's any confusion on items, I can probably help you pass those. So when creating a new object, arguments, positional parameters, yes, they are. They are positional as they're defined, and same with the method. So as this one here is saying, message and test result, when I actually create the instance of it down below, you gotta use the same order. I don't know if you can do named parameters in PowerShell. I've never actually tried that, if I can actually name it and call it. Do I pass an object in like with JSON? Yeah, actually, honestly, I've never tried hunting for named parameters. I don't know if that's a thing or not. Yeah, I don't think you can actually. All right. Well, if you guys have some questions, go ahead and toss them in the chat, and I'll keep an eye on it to kind of address those. I'm gonna kind of continue on here.
So let me know if you want me to call them out too. I can do that.
Okay. Oh, there's another one. Oh. Yeah, overloading methods. So yeah, I'm gonna have some examples here later on. That's gonna be very close to this, and I'll touch on it a bit more when we get there. Yeah, but that's a good question on overloading methods. I'll definitely dive into that more then. All right, so okay, so let me hit how to put an abstract class in PS. All right, well, I'm gonna cover inheritance here next. So this is an advanced concept that actually, so I keep coming back to this and saying, like classes, object-oriented programming, those entire college courses dedicated to object-oriented programming and books on the topic. So I'm hopefully going to get you like coupled up with this and kind of give you some like inspiration of what can be done, and hopefully that gives you to go help find the resource to really dive deep on some of these. Or I'm basically saying that it's hard to grasp this the first time through, so maybe either rewatching this video later or coming back to this material might be prudent. So, but inheritance. So inheritance. So right now I'm going to define a class that's like this base person that's, you know, the city, the full name, and two string. This is the class we've been using all along. And there's this concept of, like, sometimes you want to extend a class, you want it to do more, but it doesn't feel right to make the changes in this class. For example, let's say I want to have like a student class that has like a GPA. Well, not all persons have a GPA, but a student might. So in this case, I can actually say, I want this class to take everything from this base class and add this to it. So it's like, I'm actually adding a layer of a base class, a parent class, and a child class that are, this guy has everything the base class has plus these changes. So if I run this here, I can still have a base person, or I can have a student that takes all that stuff plus has this property of a GPA. Yeah, grade point average. So when I actually check this object here, I've got this as a property, but I can still use the base class and not have him modified. Now, where this gets really fun is we start doing this with methods. So here I'm creating a teacher. So in this case, we're just going to use a different format for the name. We're going to say, you know, Mr. Marquette instead of the name that we're using before. So here, I'm overloading, I'm overwriting. So I'm taking everything from the base person, but I'm overwriting what the get full name function does. Like even though there is a get full name in this one, I'm basically saying use mine instead. And that's kind of what we did with the toString under the covers. So if I create an instance of this teacher, and now, don't go so far, and do a get name. I can actually, yeah, so I'm getting the invocation from here. Now this also works. If you remember, if we look it back up here, toString is calling the get full name function, but in our teacher class, we replaced full name with this format. So when I see the teacher in a string, I get the function called that we replaced it with, that we overwrote it. And we can mix these together now. I can have like teachers and students together. And when we run this, the right format function gets called for the right class of the object. There's a question about abstract classes in the chat. And what that really means, what an abstract class is, it's more than some of the advanced topics, but the idea is it's a base class that you never actually create an instance of directly, that you're almost forced to create a child of. So like if I want base person to never be used, so on one hand I could say there's not really a way to do it, except you can kind of use the idea of making certain functions just not work until they're overridden. So instead of saying, what we could do is replace this and just say throw not implemented. Oh, what's that class? Oh, so if you didn't catch that, I do this all the time. If I'm trying to find a class from like C# or whatever, I'll start typing it in the brackets, not implemented, and hit tab, and it finds the full name for me. So it's like doing autocomplete. And I use it all the time to grab classes, especially exceptions. I do this. All right. So I'm getting fancy here. I'm basically saying now, if somebody tries to use this base person and the toString is called, this will fail every time. Unless I go into my person. So my student now, okay. The student has no definition of get full name, so it's going to throw this exception. So basically, it's forcing whoever's here to whoever's using this class to actually override this. All right, so we're going to use students by first name. All right, so let's load all these to kind of see what we did there. So it's not really an abstract class, but it's kind of getting to some of the pieces that you were looking for. All right, so now when I run this, we should get, yeah, hello, Mr. Marquette, hello, Alex, hello, Paris. So we did the first name for the students and the Mr. and last name for the parents. All right, let's bring this in a little bit. We can actually test to see if a class, if an object is of a certain type. So what's nice about using the inheritance is a teacher is still a base person. So if I run this, you know, we get the message, you know, let's run this. I thought that was working. What am I doing wrong here? I feel like that's not outputting right. I'm debugging on the fly now. I was pretty sure this line works. Okay, I gotta run all my code. So if the teacher is a base person or the teacher is a teacher, I'm getting these two lines outputted. So we're gonna run time. That's where you are. Excellent. So this is one way you can test if something is of a certain type. So the one place I actually use inheritance, probably most common way I use it in PowerShell is creating custom exceptions. Like sometimes I just want an exception that's just specific to my application. I can just inherit the system.exception. I overwrite the two constructors, like the bait, and then overwrite the two constructors. And then when I call it, I should get an instance of that. Now I'm using one more advanced keyword here. This base keyword is basically saying call the constructor on the parent class. So I'm kind of getting in the weeds a little bit here, but it's basically a way of saying I've got my constructor. I'm going to call the constructor of the object that's the parent class. But the long story short is now using that, I have my own exception now I can call. They'll actually throw custom messages so I can define all throughout my application. If you find yourself with lots of custom exceptions, a best practice is to create like a base exception for your whole project, and then all of your additional ones should inherit from that, which lets you decide later on, do you want to catch an individual exception? Do you want to catch all of them for your app, or do you want to catch all exceptions? Like that kind of gives you like the stepping stone of how wide your capturing is. So yeah, the most complex I use inheritance in most commonly in PowerShell is really just creating custom exceptions using this syntax. So I boilerplate, copy and paste this all over the place and tweak it as I need. Custom validators. Okay, this is kind of just a clever trick, I guess. So I actually have a blog post on this. I got the link in line in the file here. But basically, I can make a custom attribute. If I want to show you what the end result looks like first, I'm calling test validator and actually say I actually created this attribute here. Validate the path exists on this path, and then when I call it, I'll get either a failure or a success based on if the path truly exists. Now to do that, again, I'm using inheritance from the validate argument attribute to override the validate function. And this is really boilerplate. I had to copy and paste from somewhere else and tweak the contents to do what I need. But basically, I have arguments now that are passed. The value that gets passed in from path is the arguments. And then is more white space, I give one exception. If the path fails, I give a different exception. So I kind of combine these all together now. That fail? No, that was just full messages. So if I test for the Windows folder, it's happy. If I actually test the no folder, it says it can't find the specified file. All right, well, question in the comments is, how would you load custom classes in your PS module? Ooh. I'm going to loop back on that one because I have some resources that I'm basically linking to specifically about some of the gotchas and traps around loading classes. So back up here, I'm taking through, here's how they work, and I'm stepping over some of the landmines. Like there are some rough edges with classes that I do want to address a little bit, but I don't want to distract from the main flow of our document here. So I'll make note of that one and come back to it before we sign off. All right, so here's another clever use, like pipeline type validation. So using our previous class, we can actually start saying that we could be more rigid, more structured in validating our input. So you might have a function that you want to always require a person as the input. We can actually now just specify that this must be a person, and whoever's passing the values in there will have to create the person first to pass it in there. And that actually simplifies some validation scenarios when we're doing that. So I'm going to reuse that base person from up above. Actually, I gotta go fix this base person because I was tweaking it for that one example that I think is going to break some examples later on. So let's undo this. Return. 0, 1. Let's say format first, last. I should have switched these numbers here. 1 and 0. All right. I was going off script there, but I think it's going to bite me later. Okay, let's reload these. And reload this. Okay, so back to my pipeline validation. Right here. So on base assessment, we got a base person, at least. If I actually load this now, if I try to pass a string in, this is going to fail because it's of the wrong type. And it'll say it can't, so they basically can't find a string to map to on the pipeline. If I actually create a new teacher though, and pass it in, we're gonna show up just fine. And same thing if we actually create, a students and some teachers that come from maybe different sources, this function can process both of them properly. So yeah, one more way for input validation. But now, okay, so now here's a cool trick I learned. Does the PowerShell extension help you pull the classes, or do you need a C# extension? So I'm actually, back to this comment in here, back on the extensions, I'm actually pulling it just from .NET. So, and since I'm forward referencing them, I'm able to pull them. So in a way, these are the C# attributes that I'm extending in PowerShell. And the same with my exception, if I'm answering your question right. So these come from .NET C#, and I can override them in PowerShell. Okay, so back to my pipeline, base person. Okay, so here's a trick that I learned that blew me away when I first learned it. Fred from the PS framework and this more in DBA tools. So he does this thing where, okay, so I've got this person, I've got a default constructor, I've overloaded, I got a normal constructor that's taking the parameters like you'd expect. But here, I've created a special one that just takes a single string and is smart enough to actually, split this out. So here I'm splitting on the comma space, assigning the front to the last name and the next one to the first name. So let me load this class. Right? And here I can call new with this to just make sense of this person, first and last. So the way we can use this now is because I'm using I'm using that class here. Let's load this function up. PowerShell will actually try to check the constructors of the object. So if it can't find a string, right, it'll check all the parameters for strings. Can't find a string to put the value in. It'll then check all the things to see if they'll accept the string as a parameter in their constructor. What that means is I can actually pipe this in now, And PowerShell is smart enough to figure out that, this person here is the only option. And because he has a constructor up here that takes a single string, I'm going to use that to create an instance of this class, of this object. So that's some really, you can do some really unique things with that. So let's take that one step further, and let's import this local accounts module. And I'm actually going to say get the local user, which should be me. Like, take a look at it. Yep, Kevma, true. And with the properties, here we can see there's, what do we got to work with? I've got a full name property. That will have to do. All right. So what I want to do now is add something that will take that full name and convert it. I do the get member. I can see it's a type of Microsoft PowerShell commands local user. Okay. So now I'm going to go back into my class. I'm using, all right, person 7 here. I'm going to add a constructor that takes that class type, local user, of the name. And this time I'm splitting on space because it seemed to me like it was just using, first name space last name. So this time I'm splitting based on the space and using assigned to the first and last name value. So now I have a constructor that will take a local user. Let me load this guy up. So now I can use somebody's name to create an object, or I can use that other class, that other object of the local user to create an instance of something. Then we take through the same test pipeline function as before, right? And I can now pipe in both a string and that class. And you know what? My function is now smart enough to figure out what it wants to do. This is, since I'm not domain joined, I didn't do get AD user, but I could have done the same thing with that. So I could have a fancy function that could say, get my users from Active Directory, and it has the right logic for AD objects, different logic for local objects, to create those. Casting. Oh, and then back to casting, I can actually use those constructors when I'm casting strings to that object type. So I can do the same thing here, where I cast the string to the person or the local to the person. And PowerShell is doing the magic to figure out which constructor to use. So that's super awesome that it catches all that. All right. So I'm going to do one more example using the same set of logic on a different object that might be more applicable. So I'm going to create a duration object that basically can take either a time span or a date. And the idea is that if I give it a date, it's going to create a duration from between now and then. And then if I give it a time span, it's just going to accept that. That's the duration we're going with. And then if we get a string input, we'll do some magic parsing. We'll figure out if it's a date or a time span. So if I have those checks in place, what I'm able to create is a duration object that actually accepts a time span of 30 seconds, 5 minutes, or a specific date. Let's make this 20. In the future, I guess, and this is like 33 minutes from now. This is that's a UTC issue, I think. That seems that was a weird time, but no, that's 8 o'clock. Okay. So if I want to use that someplace, I can create this smart function that says start sleep duration. So we'll take a duration object. It's going to figure out all the magic, figure out if I gave it a date or a length of time, and I can sleep now for that amount of time. So if we run that, I can now sleep for 5 seconds. We can actually do a get date and add 5 seconds to the date to sleep to that point in the future. And then we could also do 27, 59. Or we could sleep for just 46 seconds by giving a very specific time in the future. So, this is a very clever use case. I've only ever seen it used in the PSDB tools or the DBA tools and the PS framework, but I thought it was super clever and it opens up a lot of possibilities. I can't say I've actually used this in my code directly, but it's a tool I have in my back pocket in case I ever need it. And I've got some, so now I've got 2 examples in here that if you need to go back and reference it, you can dive into it and see. There's a discussion that continued while I was going here. Looks like that got answered. Awesome. Okay, so now I actually want to go full circle to DSC resources, which is the entire reason we have classes in PowerShell. Like the main purpose of classes was for making DSC resources easier to create and work with, and to entice developers to make DSC resources. So I'm kind of glossing over it, but here's how you make an enum. This kind of comes hand in hand. So this is an enum that has 2 values, on or off, and it's only in here because the sample code uses it. So for a DSC resource, you kind of need just a couple things here. I'm going to class these to begin with. So, DSC resource actually uses these attributes to kind of describe pieces of the class. So basically, we have a DSC resource, which is actually a normal class. DSC property, this specifies the key. It knows that this is the key to kind of decide uniquely on if these resources get duplicated or not. That this is the one that is like the primary key of this resource. And this is a super simple one because my state can only be on or off. So it's so it's kind of a state of on or off, and it has to have these 3 functions: a set, a test, and a get. Like this is what a the DSC as a PowerShell 5, the new style DSC resources. This is the structure for them. So looking at this one for firewalls, this guy's checking if on the set the firewall is off. We're actually using NetSH here. I'm sure there's a PowerShell way to do it as well, but I think we're supporting some older systems on this. So like 2012. Anyways, we're turning firewalls off. If state goes on, we're turning firewalls on. Else, it's an invalid option, which you can't really have since there's only 2 options, but good feature grouping, I guess. And the test is deciding, hey, do we is the state ready? Is it configured as it's supposed to be? So we get the current value. We're actually counting how many of these are turned off, and if all 3 of them, all 3 profiles are set to off, we're turning, and we want to set it off, we say we're good. And if all 3 of them, if none of them are off, and we want the firewall state, wait, my logic backwards. Anyways, the idea is that we check how many firewalls are turned on, and if the state matches, we say it's true. If not, we say it's false. And then there's the get. So Pester or PowerShell DSC is doing the get and the set calls and doing the test calls to decide if it wants to call the set or not. So yeah, so this is so much simpler than the creating the scripts for DSC resources and then creating a MOF to handle the schema pieces of it. The class now is the schema for the classic DSC resource. All right. Let's see. We're going to talk about. All right. So I do want at this point. I definitely want to call out. Brandon Olin did a great session, PowerShell Summit, 2 years ago. I've got a link to it here. And they're saying developing PowerShell classes like here be dragons. He does a great job of painstakingly going through all of the rough edges of classes. So the further away you get from DSC resources, and especially if you're coming from like C# and you know a lot about classes, the more things you're going to find you just don't like about them. Like it's a very simple implementation. So when you want to do something like inheritance, like, oh, that doesn't exist. Somebody mentioned abstract classes. You know, that's something that we kind of cheat on. So another challenge he does a great job of walking through is that when you're loading classes, ways to load them in different ways to make sure your dependencies are accounted for and cross-module class work. So my disclaimer is, if you keep all of your classes in one module together, it's a lot easier to work with them. If you're starting to do some like cross-module stuff, there's a lot of traps in there that I mean, the short story is that PowerShell modules don't export classes by default. So correctly getting them loaded across modules becomes a challenge. What I tend to do is have like a function that says like new person, like actually create the functions that kind of wrap around and hide the pieces away from the users. So this is definitely a must-watch video if you're working with classes, especially if you go beyond the basics that we covered here. When it comes to loading classes, so that's actually one of the problems. So if you're using a class in a function, it has to be loaded first. And I like to have all my files broken out into individual files. So I have like a file per class. And if I try to dot source those in, if I don't do them in the right order, I'll get errors, because like you actually have to load classes in order that they're going to be used. I've got an example module, and I go through great. I go through a lot of work to kind of get around that. So I've got sample code here. We're kind of going to skim through it, but it's going to be, I'll make sure that this gets in the repo as a reference. But basically, the idea is that I want to load the classes in order. So I'm basically going to walk all my class files to figure out if there's anything that's using inheritance and basically figure out the order on the fly. So here's a case where I'm loading classes from the classes folder. So I structure my files are structured, so I have classes separate from private and public functions. So when I want to like parse and pull out the classes, I can just enumerate that one folder. So we're going to walk every class file, and then in that, I'm going to make a reference. Basically, I'm creating entries in a hash table that I do some regex parsing to figure out if a class is inheriting another class. And if I find that, I'm adding an entry to the hash table, and then I'm calling another function of mine, resolve dependency order. Like it basically sorts things based off dependencies. And once stuff is in the right order, I import those. It feels dirty going through all this work just to import some classes so I can keep them in separate files. But I definitely like having them as separate files. Like the way you work around that would be you just put them all in your PSM1 until you've got enough that you need to break them out into files, and then come hunt down this solution here or something like it. And Brandon does a great job talking about those nuances. So from, I guess, that's a great point to check in on questions. From here on out, I've just got some real world code examples of classes in use. The examples are, yeah, I got examples of both using DSC resources and of classes in a couple of the module projects that I'm gonna start like poking at and diving through. But yeah, so keep those questions coming, and I'll work to answer those, and we'll kind of help fill the time with what your questions are here. And I guess before I actually start showing my code examples, I want to bring back to that. There's a you'll find stuff where somebody's using a class and coming from like the PowerShell admin, the system engineer or the sysdev might think like, oh, we could just use functions for that, or why can't we just keep the PowerShell simpler by just using straight PowerShell versus stepping into classes? And some of that might come from somebody that's worked with classes. They've got this whole tool belt of their own tools, and there's some common principles and design patterns that you kind of learn along the way that kind of give you more depth, and classes kind of go hand in hand with some of those design principles. I'm going to highlight just a couple of them here. So a very common set of principles is called SOLID, for solid development, by darn, I've lost his name already. But he came up with a list of design principles. So we have this idea of like the single responsibility principle. Like you probably heard it said before that functions should do one thing only, right? It's like there should be one responsibility for this. They take it a step further and basically say that there should be only one reason that you're ever making modifications to this code or class. So that basically keeps classes smaller and single purposed. So they do one thing and just does one thing well. The other one here that's pretty strong in the community is like the open close principle. And the idea is that it's open for extension. Like once you've built a class, you can extend it by inheritance or probably using interfaces. And then, but it's closed to modification. So the idea is that once you create your class, you generally don't go back and modify them as much as you would like extend them for other uses. So make them for a specific purpose and keep them for that specific purpose. And I'm going to just skip over these other three just because they really don't have an equivalent in PowerShell whatsoever. And then also highlight these design patterns. So like this is like a toolbox that systems or software developers use as they're constructing classes in different ways to solve different problems. So there's like 12 or so, or maybe more, common patterns. So it's like we have in PowerShell, A pipes to B pipes to C, but object-oriented programming has this whole tool belt of solutions to problems that developers like to reach for solving problems. And this is kind of why you hear that group calling for classes, because it's a very class-based approach. Like a proxy, like we're all familiar with proxies in enterprise engineering, where it's like, all right, I've got one resource that's hidden behind something, so I'll have something in the middle that kind of brokers the connection through. And there's equivalents across all those. I'm not going to dive through this. I just want to highlight these so that you guys are aware of them. It's good reading. There's books dedicated to this, whole books on these design patterns and how to use them. So I wanted to highlight those before I jump into the code, because that kind of, some of the code we're going to look at was probably driven and inspired by. Oh yeah, I'll drop those links in the chat. And these links are in the GitHub commit as well. So I'm highlighting these because some of the code we're going to look at was probably driven by some of these decisions. But if I thought about it hard enough, I could probably do in straight up PowerShell without using classes at all. All right, so I guess I could peek at another DSC resource. Event log. All right, repository registration. That's a pretty common topic. So here's a second DSC resource that I got 2 enums for defining installation policy and just sure if it's absent or present. And then as I define the class for my DSC resource, I'm saying that this is the key, which is the name of the repository. We've got a mandatory property, which is the URI, so we know the path to it. And then an optional DSC property, which is installation policy. And then the DSC property that says, are we going to, it's optional to ensure if we're going to make this repository present or not. I got some helper functions for remove and create a repository. So removing, we're just going to say get repository where the name matches, and then we'll unregister it. And then the create is our exact reverse, right? Here's our properties. We'll slide it to register PS repository, and we're off and going. So I actually use this resource here to install PS repositories and modules on servers. Like this was, the limitation is this is scoped to the DSC system process. Like it wasn't creating it for all users, but if I need to install modules later, it could do so. All right, then my set is, I was being lazy. I said, you know what, if we're gonna make a change, let's remove whatever's there. And if they ensure it's present, we'll create it. The test is getting repository, checking all the values, make sure everything looks kosher. And it is configured equals true. Else wasn't false, found. And we do the switch off the ensure present. The handle logic is configured or not to return back a true or false value, since the test should always have a bool as a return type. And then get gets back the values. I'm creating a new instance of a repository and populating it as we go from the get PS repository, but I've seen many people take a shortcut and just return this here, which I think today the get method isn't really used much in PowerShell. It's often neglected, but properly I would create a new object, populate it with the properties of what the current system is, and return that object. So the get always has a return value of the class type that is being defined. And yeah, so I think it's a nice, simple DSC resource that I definitely like these better than the other approach. Oh yeah, thanks for the fresh link to the GitHub repo. Yeah, all my links are in there as well. So it's a good one to bookmark. Okay, so let's dive into an actual module here. Let's see which one I want to do first. Let's do this one. All right. So here is a module that's specific for managing load balancers on an on-prem environment. Actually, no, I take it back. That's the other one. This one is another scenario where we had like a central configuration that was actually setting up pipelines and for applications and executing the test packages that were associated with them. And we actually had like 4 or 5 different types of tests that could be set up. We had batch files, we had node projects, we had NUnit tests, we had pester tests, because of course, and VS tests was another option that our devs could use. So I set this release test. What's my base class here? So I take a peek at this guy, KFS release test. All right, so okay, so a common pattern when thinking if I should be looking at using a class or not, one common scenario is, like I say, if you have lots of repeated code, you create functions so you're not repeating the code so much. But if you find yourself having a very common pattern of creating the same types of functions over and over, that might be a clue that a class might encapsulate that better. So if you're finding a very repetitious amount of functions, that might be a strong case for using a class. And the other flag that I usually look for is if you're doing a lot of switch statements on the same thing over and over. Like if I've got a switch statement like on my processing or on my retrieving of data, and I got a switch statement on my processing of it, switch statement on my output. With classes, you can often replace all those with a single switch statement that gives you a class, an instance of a class that can then has the logic it needs, and then you just call the functions down the stream. So if I was trying to decide from the PowerShell point of view, do I need to think about a class? If I'm using lots of switch statements for the same thing, and if I find I've got this pattern repeating itself in these functions. So with that, test state. All right, so here's my base class. I've got some like state machine type functionality here. So in my pending, running, skipped, passed, or failed, and I've just got helper functions for this to kind of abstract away the use of that. So it's basically a set pending, set running, set failed, set passed, set skipped, and to get the current state. So this makes it the state tracking class. I actually have this base class, this release test, that inherits all of those properties and has stuff specific around testing. So the name of the test, what it depends on, it depends on other tests, folder locations, and the type of tests that we're processing. Out of the gate, we set some default values. Here's a case where I specifically chose to set the values in the constructor so that I could override them, I think, in the other classes if needed. ToString, we've talked about that. So then we basically start the test, and through all the validation here, I'm capturing stuff. I got a try catch around everything. So if there's any problems at all, that gets bubbled up, that fails. And then I'm calling this execute command, which is very specific to the actual execution of the test itself. Yeah, so that's where I actually execute the code. We're getting the output. We're nicely tightly controlled around this guy for failures. And then at the end, here I'm using the abstract idea where I'm throwing an exception, so everybody has to implement this executed test command. And then I got something that's going to publish the results. This is the folder. So now I've got that structure in place. I'm saying that I'm going to have lots of classes that have their execute command isolated to just themselves. So if I go to my batch test, actually let's go to this to tester first. If I go to my tester test class, here I'm changing the result types to NUnit, and then I have to implement this execute test command, where we set the parameters, add some tags, call invoke pester, check for errors. If there's no errors, we set the test as passed. If there are errors, we fail it. And now I have only thing in here is code related to executing pester. And this pattern repeats itself. If I go to a batch file, we basically execute the batch file with any parameters, and we check for last exit code. Like there's not a lot you can do with a batch file. Like it either works or it doesn't. And some of these are more complicated, more work, but it's parameters on the thing. But it's this idea that I've got the same pattern. I'm going to have lots of different things. So I've got this configuration that knows what different types of tests that need to be ran. and it's going to generate these objects. So if I actually look at the public function, the new TFS test release, then here's my one switch statement for this. So now I've got a function that says, based off the data coming in, based off of these parameters, let's create these instances of a PESR test, a VS test, node, unit, or throw an exception that doesn't match. And that's how my logic is able to have only one instance of the class and have unique classes for each different test type. So the question I have is, do you have any examples of repetitive functions that would have been better as a class? This one, I think, is one's like borderline. Like if I would have thought about it hard enough, I guess I had one giant switch statement. So in a way, in the end, I only had one function I was overriding. I think I intended to have some of the reporting or handling of the results of the tests, but it turns out I didn't need that logic in here. So this was the case where I would have like two functions. One was execute the test, and the second one would have been like handle or process results. So that's a case where I probably had two giant switch statements. So you could easily make the argument that these could have just been PowerShell functions that were called to do this logic in a giant switch statement somewhere else. But I think I had extensibility plans for this, is why I went down the path of classes. So an example of repetitive functions. So actually, this other module here, it's a very similar story of, this is my F5 configuration that I kind of alluded to earlier, where I got the configuration data, I configured load balancer, and this is the case where I actually have a class for every different object type. For every different object type that we have in a load balancer, we got the global traffic manager pool members, health monitors, iRules, local traffic managers, local traffic manager pool members, virtual servers, and DNS white IP addresses. Like there's multiple objects for each of different things. I think I have a stateful object that these inherit from that manage, if I give my ability to say enable or disable. So I believe I have a function. Maybe we don't have it as a function. Oh, we don't. We should have. All right. So what I can do now is I can have my get function is ugly. Get. Where is that function? Where's this reference at? All right, so when I publish this anyways, publish F5 object. There's already a lot of repetition in this guy already. Like, so instead of having like a publish method for every one of these, we've actually got it on the class. And what I can do is I can say get all my objects. So I can say, get all my configurations, which is give me my nodes, my hosts, my load balancers, my zip, my help tests. And then we pass it to this publish LDF5 config that will take all the objects in and then test the state. If the state is not configured properly, that's where this test comes in. Or we say force to say, I don't care, just blow it away. We call the set on the object. And this is I think we're going back and basically refactoring back to this type of a pattern where I could just now have this one function that's doing all my publishing, and we're then keeping the logic for setting the details local to the class. So I'm spreading across having a class itself. Here's a good one, health monitor. Where else this guy wants? The set logic is deeply ingrained right here, together with, we got the test results, the get, and some helper functions. So in this case, I've got a get and a set. The logic is tightly ingrained here. It's kind of kept together with this type of a thing, and yeah. And we definitely used, we were basically inspired from DSC a little bit on this, right? Like this get set test. I expect that I want to actually be able to get the results so I can actually report on them better from the test results. And with all the properties that you need for a health monitor in here. So this is one where I have tons and tons of classes, and I still got tons of methods. One that I think was done cleaner in that, actually I've got both the old and the new methods in here, but the app settings, I kind of went pretty crazy with the classes in that this is what's like applying configuration file settings, and I could be configuring a app config file. We could be configuring an XML or JSON based config file. It could be a web page that's got token replacements. So basically, I got key value pairs I'm trying to inject into another system. So we have this higher level of config transforms. So I'm configuring a Chrome manifest file, an XML file, and the idea is that in here, if I get an ugly one, like say the XML config, there are lots of different things in there that can be configured, such as app settings, connection strings, session state, XPath, enforce settings, and things of those nature. So here I was able to make specific classes that do those things and composite them together for the XML config. If it's just a JSON file, I can have just a JSON transform. If it's JSON core config for .NET Core project, we'd have both the app settings and connection string settings that are being applied. So it's a composition of lots of objects together to apply settings based off of those specific needs. All right, so way down the weeds on this one. This one is actually lots of different classes, so it's kind of hard to actually go through pretty quick, but it's definitely a case where I was able to cut back the functions drastically from what it was down to mostly classes and a call to get the class, do the logic, and set the logic. All right, well, I think we're kind of at time here, and I'm sure that I kind of got the weeds here towards the last bit of it. So, and I think I've already highlighted all the resources that I wanted to highlight here off of about classes and little examples. So I'll say this is kind of wrapped up everything I had prepared to present. I can definitely field questions, and it kind of what questions you guys got or feedback, and kind of go from there. Like I said, it's kind of an advanced topic, and the further down we got, the more in the weeds we got. But hopefully I kind of inspired you guys into what can be done. So when you're ready to, do it, you kind of got a tool in your back pocket to kind of find these resources again later. Yeah, awesome. I appreciate that. I definitely need to get back to writing. I've just been kind of busy, focused at work, and I've been inspired to write documents. I might turn this into a deep dive document since I've already done a lot of the work for this presentation. A lot more to add to clean up on it, I think, but this has been my first run through on this content. So Any good module examples which use classes besides mine? I think PS Chatbot, one comes to mind. They use classes and custom attributes, I think, very cleverly inside that project. And it's actually Brandon Olson as well. I think I dropped a link to his blog, and that's, I think, probably the project that half drove him insane is why he made that presentation. So yeah, the PS Chatbot, that's the definitely go-to module for stuff that's not mine.
I would bet DBA tools makes heavy use of classes as well.
Yeah, DBA tools and the PS framework. In fact, I mean, actually, so the trick where I was taking data like a string or a date or a time span to create a duration object was pulled from the DBA tools. Like they were actually doing like the connection string. You can have, an AD object. You can have a connection string and different type of objects passed in, and it just figures out what it is and goes on with life. So it's very beautiful.
Francisco, you have an interesting point. So a class doesn't replace a function, in the same way that a class may replace a less functional PS custom object or a less functional hash table like Kevin was showing at the beginning of the meeting. It encapsulates so much more than just the capabilities of a single function. You can think of a method like the method of a class as a function that is built into that class that acts specifically on that class or on an instance of that class, as well as other objects. So it's kind of hard to say that a class can replace an entire function. Now, I will say I have seen plenty of cases where somebody is kind of warping a function to do much more than it might need to, maybe to replace some of the things that abstracting that functionality or that data structure into a class makes more sense. But I wouldn't say in the classical definition of a function that a class would replace it.
I suppose a good thing to recognize is if you're using the same parameters a lot for something, like you find yourself just having this big chunk of parameters that got to pass around to a lot of things, you can do one of two things. One is replace those parameters with a class, just pass the class around, which will make your definitions a lot smoother. Or take those set of functions and make those all in one class together, and those parameters could be properties of that class. Now, this is for like your internal stuff. Like if you're like anytime I'm exposing to my users, like the commands I want them to run, I'd be fine having the proper commands there. But sometimes when you get like nested functions, like a function is calling a function and calling another function, like the idea of if you start getting smaller and smaller as your functions, you will find yourself passing more and more of the common sets of data around. And that might let you find a grouping to pull together into, let's put this in the class. I can use these parameters, and then it's called a simple function. And it makes functions super lightweight. Like here, I'm just looking at one of them. Like I have no problem creating a function with a single line of code if it makes it easier to work with. So many of these functions fit on one screen. And I think it's super lightweight to create functions or methods in classes to keep code super clean. So if you're finding yourself with, lots and lots of code, start breaking them into functions and start finding functions that have similar parameters. You can maybe group those into a class. But I do definitely want to say, don't force classes. Like if you're finding your PowerShell itself is working, like I think as you drive deeper into like software development and start reading, taking the classes on like the design principles and design patterns, you'll find more tools that says, I should probably use a class for that, and probably come back to PowerShell that way. I think it's really hard to go from the admin writing scripts to the systems engineer and figuring out where classes fit in from that path. It's like you almost have to go down the path of a true software dev to come back. You don't have to, but I think that's where you'll find the most value out of it. And then some things will just pop out. You're like, oh yeah, I think I can just use a class here, and be up and happy. Awesome. Yeah, I hope this was helpful, guys. Like, it was tough gauging, where to go in super deep and where not to, and I always end up going super deep at the end, no matter what, on all my talks.
You always have a nice range.
Yeah, I try to have something for everybody. So people that haven't seen classes before, hopefully, I got the nice soft intro, and people that play them a little bit. I'm hoping there were some gems in there that you hadn't realized were possible, that you're walking away with something. So.
For sure. I'll go ahead and stop the recording and we can finish up.